Now let's move on to the mapping diagram. So again, ordered pairs, tables, and mapping diagrams. We write or notate the domain range in the same way, so we're going to use set notation. So for mapping diagrams, it's just another way of writing a table or another way of writing your ordered pairs. The circle on the left is going to be all of your X values or your inputs. And then the circle on the right will always be your Y or your outputs, so for your range. So again, domain in the other displays was green, so I'm going to use green to represent my domain. So I'm going to then write my domain using set notation and organizing it from least to greatest. So -7, 0, and 3 are the numbers that I see in my domain. For my range then, or my Y values, input values, or dependent variables, I'm going to use purple to go ahead and highlight that. And again, I'm going to use set notation, and I'm going to organize those numbers from least to greatest, where there's only 2. So 1 comes first, then 2, and then close off with a fancy bracket. So then to determine if it's a function or not, again, a function is for every input, there's exactly one output. So as I can see, -7 goes to 2, 0 goes to 2, and 3 goes to 1. Some folks might get a little confused because they notice that both -7 and 0 both have an output of 2. And so they would automatically think that this would not be a function, but that is false. Because -7 is a different value from 0, it is still okay that they go to the same output value. So this mapping diagram does show that there is a function. And again, like the others, if I took time to plot these coordinate points on the coordinate plane and draw a vertical line, I would see each of those points would not be on the same line. So again, to determine function or not, every input has to have its own output. So that means if there are 2 of the same inputs with different numbers, then it's not a function. But you can have 2 different inputs have the same output. That does make a function. So that's something to note as we go forward, because that does get a little tricky. Now let's move on into graphs and equations. Graphs and equations are a little bit more abstract, and it takes a little bit more time in determining the domain and range, just because it's nice to have a visual, and we also write it using interval notation. So again, ordered pairs, tables, and mapping diagrams are written using set notation with those fancy brackets. Graphs and equations, we're going to go ahead and use interval notation. So when I look at a graph, having a visual is nice. So when I look at my domain, remember domain means X values. So all X values that work. So what I want to do is I want to notice with my eyes that the graph that I see here is a circle. Okay, so the picture of a graph on this coordinate plane is a circle. And what I want to draw my attention to is where this circle crosses the x-axis. So I see it touches the x-axis at this point over here, and it touches the x-axis at this point. So the only parts of this circle that are touching the x-axis are these 2 endpoints. And then I'm going to draw or connect those 2 lines in between. What's important to note is that even though the farthest left that my domain goes is -4, all of these values inside are part of my domain. And then my domain ends at +1. And how I know that is because, again, here's a coordinate plane. Right here is 0, 0. And each of these units go by ones. So this is 1, 2, 3, 4 along the x-axis. And then this is -1, 2, 3, 4. So negatives along the x-axis to the left. And then the up and down axis, remember, is our y. So again, what's really hard is with graphs, you need to be able to read graphs like a book. So from left to right, how far left to how far right does this graph go? It only goes to -4 and +1. So under the word domain, I want you to write in parentheses, how far left to how far right? So I want you to write that question down because that's what you should be asking yourself to identify the domain. So the farthest left number it goes, we said, was -4. And the farthest right our domain goes is a +1. So here I have -4, comma 1. And with interval notation, if you remember our notes from the last video, interval notation means we have to decide between parentheses and brackets. Parentheses means that our endpoint or our value is not included on the graph. So that means the graph does not go through it. And the endpoints or the brackets here mean that the endpoint is included. So the graph passes through that number. So now if we look at our graph here, our graph of a circle passes through that -4 point and through the +1 point. So here's where we would use brackets. -4 is included in the domain because I can find a coordinate point on my circle graph. And +1 is included in the domain because I can find a point on my circle graph. And what this means is with these brackets, all numbers, whether they're whole numbers, decimals, fractions, whatever it may be, all numbers in between -4 and 1 are part of this graph domain. So then for the range, remember the range deals with the y-axis. I'm actually going to highlight the y in purple and the x here in green for the domain. So I should have done that earlier. But the range here, you need to look for how far low to how far high. So that's a question I want you to write underneath. How far low to how far high? How far low to how far high? So you really need to train your eye to look at a lot of things. You need to train your eye to look at the axes, and then you need to train your eye to look at the actual graph or the image that's being displayed on the coordinate plane. So when I look at my range, I'm looking at the circle graph again. I want to see what's the lowest point this graph goes to, and that is actually right at -2. And then I want to see how far high this graph goes. And how far high on the y-axis is that it actually goes to +3. And then I'm going to go ahead like I did before and connect that with the highlighter. So how far low to how far high? So again, on the coordinate plane, this is my y-axis, so I go down 1, down 2. So the lowest it goes on the y-axis is -2. I'm going to write that right here, right on the y-axis. So the lowest point this graph goes is at -2 on the y. So then if I'm traveling up with my eyes along the y-axis, I want to see how high it goes. And that is at +3. So again, I'm not looking for the actual coordinate point. I'm just seeing how low on the y-axis and how high on the y-axis this graph goes. I should probably zoom in a little bit. Sorry about that. I should have done that earlier. So again, we're going to use interval notation. How low is at -2 and how high is at +3. And again, my circle graph goes through both of these points. So I'm going to use brackets. These brackets show that -2 is a value for the range or a y variable, and 3 is also a value for the y. So what this means is any number, whole number, decimal point, or fraction in between -2 and +3 on the y-axis is part of the range. And then finally, I need to decide if this is a function or not. What's nice is that this is an image, and so if I were to draw a vertical line anywhere on this graph, I would see that my vertical line would go into many different spots of the graph.